Welcome to part 2 of F5 Distributed Cloud on multi-cluster, multi-cloud networking for Kubernetes. In this part 2, I'm going to share the deployment guide of the architecture pattern explained in part 1. This video demo is not a recording of the steps required. Please refer to the articles for steps to set up the environment. The objective of this video is to demonstrate the outcome of this deployment guide. I will also demonstrate how you can achieve cluster resiliency and security protections of applications and API running across multiple OpenShift clusters. Before I start the demo, let's have a quick recap on what is F5 Distributed Cloud. It is a SaaS-based service delivery platform that automates the deployment of application security services, application delivery across location, apps-to-apps networking, and deployment in containers as a service for distributed workload. This unified platform brings value to organizations where it helps organizations in applying consistent security and policy across multi-cloud environment or sites. It streamlines the application-to-applications connectivity as well as provide full observability and analytics with centralized management. In this demonstration, I will demonstrate how you can deploy consistent security and policy across a fleet of OpenShift cluster and streamline the apps-to-apps connectivity that provides a highly resilient application across multiple OpenShift clusters. Before I explain the demo environment, let's have a quick recap on Distributed Cloud Mesh architecture pattern described in Part 1. Please refer to Part 1 videos or articles for further details. Architecture Pattern 1 allows you to run Cloud Mesh as container native pod. In this deployment pattern, Cloud Mesh pod run inside OpenShift cluster. Architecture Pattern 2 allows you to deploy Cloud Mesh as node. In this deployment pattern, Cloud Mesh node run outside OpenShift cluster as a virtual machine and function as a secure Kubernetes gateway to the OpenShift cluster. Cloud Mesh node performs service discovery of pod's lifecycle. Architecture Pattern 3 is a combination of Pattern 1 and Pattern 2. It's hybrid patterns. Cloud Mesh as hybrid will be demonstrated in this video. To demonstrate the outcomes and values of F5 Distributed Cloud Mesh, a sample application will be used. Here is a sample application called Arcadia Finance. It is a modern application where it consists of multiple microservices. It has front-end, back-end, refer friends, and money transfer microservice. This is the detailed constructs of Arcadia application. Arcadia modern app consists of multiple containers and Nginx API gateway. User interact with the front-end as well as the trading API gateway. Front-end integrated with respective microservices via an API call and back-end web services call. Those respective microservices such as refer friends, money transfer, and back-end are distributed across different locations on OpenShift cluster. Let me explain the demo setup. I have 3 independent OpenShift clusters located in different data centers. One in Hong Kong, one in Australia, and another in Singapore. Apart from OpenShift, I have a legacy data center where I host my Arcadia backend database. This database runs as a VM and acts as a disaster recovery copy. In OCP AU, I have a cluster of Cloud Mesh pod installed as well as front-end microservices deployed. In OCP Hong Kong, I have a single Cloud Mesh pod installed and money transfer and refer friends microservices deployed. In OCP SG, I have a single Cloud Mesh pod installed and backend database microservice deployed. In Sydney SYD Mesh H1, I have Cloud Mesh node spun up and Arcadia backend database for the Arcadia Finance application. As mentioned, this is the DR copy of the database for OCP SG. You may also notice that I have money transfer and refer friends microservices deployed in OCP AU and I label it as Site 2. This is the backup or DR copy of the money transfer and refer friends for OCP HK, which I label as Site 1. Those backup or DR microservices can run as a active-active or active backup. This application is currently being advertised and accessible from the internet via F5 Distributed Cloud Global Backbone and protected by Web Applications and API Protections Services. All Cloud Mesh port and nodes establish a secure encrypted IPsec tunnel among each other to form what we call a secure application mesh fabric. Communication between each microservice traverses this full mesh fabric. Communications are default denied unless administrator creates specific policies, load balancers, and rules. Policy enforcement and protection, such as web application and API protections, are implemented in transit to respective microservices defined. Let's jump into the demo. This is my F5 Distributed Cloud console. Here is my Australia OpenShift console where Cloud Mesh port installed. I also had application ports deployed in Arcadia OCP namespace. Similar in OpenShift Hong Kong, Cloud Mesh port and application port deployed. Same with OpenShift Singapore. Arcadia Finance Modern application is deployed across multiple OpenShift cluster. Here is my CLI view of 3 OpenShift cluster running in multiple data center. I have OCP AU, which is 3-node cluster, OCP HK, a single node cluster, and OCP SG, a single node cluster. Front-end ports, money transfer, and refer friends, and back-end port respectively deployed in OCP AU, OCP Hong Kong, and OCP SG. On top of that, I have money transfer and refer friends with a -B as the backup DR for OCP Hong Kong. What's not shown here is a backup backend database on a VM. First, Cloud Mesh port and Cloud Mesh node need to be registered onto the console. This can be done with a simple node provisioning and registration. As shown, I have 4 sites where Cloud Mesh registered and healthy. Currently, site mesh group is not configured. Now, I'm going to demonstrate how you can easily create a secure application mesh fabric by simply attach a pre-configured label to create a virtual site. I'm going to create full mesh between OCP AU and OCP Hong Kong. I just need to label both sites with the same tag. I call this tag platform equals to OpenShift. Now you can see that secure mesh fabric created between OCP HK and OCP AU. I'm going to repeat the same task for OCP SG as well as the Cloud Mesh node. This mesh fabric will facilitate the data path between OpenShift cluster later. As seen before, I just need to label Cloud Mesh node and Cloud Mesh port with the same label. This will create a virtual site and group all those ports and nodes as part of the same group. Same as Cloud Mesh port, I'm going to label Cloud Mesh node with the same label as the rest. With a simple action, secure application mesh fabric created among all those Cloud Mesh and they are all healthy. This action can be automated and orchestrated with an API. These are all the relevant HTTP load balancer being set up for Arcadia and API gateway. As mentioned, this application advertised and accessible from internet. This is the Arcadia Finance application. It is a simple financial apps that allow you to log in and perform some financial transaction. The default portfolio balance is around 29,000. As you can see, quick money transfer module being served from site 1, which is in OCP Hong Kong. As for Refer Friends module, the email failed show its response by site 1. Currently, both modules runs on site 1, which is on OpenShift Cluster in Hong Kong data center. Now, to simulate a failover, I will delete and terminate the microservices deployment on OpenShift in Hong Kong. I will first destroy money transfer microservices. As you can see, money transfer in Hong Kong OpenShift currently in terminating state. If I refresh my browser, you can see now that quick money transfer now being served from site 2. Money transfer services seamlessly redirected to site 2, which resides on OpenShift in Australia. Refer Friends services still serve from site 1. I'm going to repeat the same to Refer Friends so that Refer Friends fail over to a backup site. Money transfer and Refer Friends will be served from the backup microservices from secondary OpenShift cluster. Now, if I access Refer Friends module, Refer Friends serve from site 2. This demonstrated the seamless failover and high resiliency of the application. In this demo, I run service as active standby. This can be configured as active-active. Now, if I terminate the backend service on OpenShift Singapore, this service will fall back to on-prem legacy data center database running on virtual machine. Default portfolio balance as shown around 29K. This value obtains from backend database from OpenShift. After a failover, a portfolio balance of 30K being obtained from the backup legacy database. This is how F5 Distributed Cloud able to seamlessly fail over your application regardless where your OpenShift cluster. Now see how F5 platform able to provide full observability and analytics with centralized management from single console. From App Traffic's dashboard, you can visualize your distributed apps and the traffic's flow between each component. It shows those relationships between each cloud mesh in relation to the microservices deployed. As you can see, we have some unhealthy traffic flow between clusters. Those are expected as I had synthetic traffic generator sending good and bad traffic. From Security Dashboard, you can obtain a quick snapshot on various security metrics and security posture of your application. You can deep dive into a specific application load balancer to see the in-depth security posture. Here, I double-click into front-end load balancer, where this load balancer being exposed to the internet. Front-end constantly being attacked and being mitigated by F5 WAP. Here are those API discovered presented in an easy-to-consume way by leveraging F5 AI/ML learning engine. This platform provides API discovery, where it discovered known and unknown or shadow API. This platform also capable of identifying and baselining the authentication states of the API within your environment. A lack of authentications of API calls is considered a risk for API. It is extremely important to have visibility into state and type within this API. In Arcadia Finance, JOT token is being identified. It provides details and insight on security posture and vulnerabilities of those discovered tokens. Let's move on to bot defense. Bot defense protects your internet applications from automated attacks by identifying and mitigating malicious bots. Let's double-click into bot defense detailed dashboard. From this dashboard, you are able to identify various bot intent and mitigations actions efficacy. Bot defense dashboard provide rich insight on impact of bots to your application. Malicious user page provide a global view of attacker for a specific namespace, along with the ability to obtain specific malicious user details. When malicious user mitigation is enabled and malicious user behavior is tracked, the system tags the user into threat level high, medium, and low. Threat campaigns page provide insight into the full context of the attacker along with the origin, threat campaign's attribute, and description. Protection is based on a variety of threat intel sourced from the real-world campaign to attack and or take over resources. Its signatures are based on current in-the-wild attacks. Those are outcomes and values of how F5 Distributed Cloud Platform brings. It brings the power of simplicity to reality. Hope you enjoy the demo and please feel free to reach out for further deep dive session. Thank you.